Hi, and welcome to the video course, Interconnecting Cisco Network Devices, ICND1. My name is Patrick Lohner, and I'll be your instructor on this course. We're going to start just with a little bit about my background. I've been in the IT industry, both working and training, since the late 90s. I got my start at a training facility. Early on, was certified in several CompTIA certifications, CCNA, and Microsoft Certified Systems Engineer certifications. For the first several years, I not only did training, but I also worked on that networking environment as the network admin. During that time, configured switches and routers, firewalls, dealt with network connectivity, troubleshooting, even made some design changes along with working a lot of times on the software side of things, the Microsoft network services as well. Second place that I worked at was more of a consulting agency. We were the help desk and support system for small businesses in our area, but would also partner with medium to large enterprises for particular projects. Some of those would be network related and others would be more of the software and network services types of things. And then for the last 8 to 9 years, I've been working as really a freelance IT contract trainer as well as consultant. During those times, again, we've kind of touched a lot of different areas, both on the software and the networking side. Now, ICND1 is sort of the benchmark certification or benchmark training for the CCENT certification. Coupled with ICND2 is the CCNA certification. And really this is a foundation for anybody who wants to get into networking. I originally got my CCNA, for instance, back in the year 2000 and have continued to keep that up to date so as to be knowledgeable on new features, new products that Cisco and others have released. And so it's very important for you as well, which I'm sure you know, and that's why you're watching this course. So what are we going to be talking about? Well, a lot of fundamental concepts are going to be what we're going through. If you have some background in networking, you may be familiar with some of these things, but I think we're going to dig much deeper than you may ever have before, specifically in the area of the configuration of switches and routers. We're going to start just with some network fundamentals. So we're going to dig in and look at what makes a LAN, what's the difference between a local area network and a wide area network. Dig into the concepts of IP addressing and routing and looking at TCP/IP in depth as a networking model. Then we'll look at some basic Ethernet LAN implementation, the command line interface and the Cisco IOS on Cisco Catalyst switches will be our predominant focus. What commands do we use to configure switch ports? What are the different options that are available, and how do you get comfortable with iOS and its command line interface? We'll look at designing and troubleshooting Ethernet LANs, standard LANs, and then we'll also broach the subject of virtual LANs, which are heavily used when dealing with switches on enterprise networks. We are going to spend a ton of time on the IPv4 addressing and routing concepts. This is very critical. It makes up a large portion of the exam. We have to be able to look at an IP address and a subnet mask and derive key facts about it. What class of network is it on? How many hosts are available on that network? Has the IP address been subnetted? What network, what address should the default gateway be? We're going to go from start to finish. We'll start sort of basic and then we'll start getting more in depth. We'll look at things like variable length subnetting and advanced design concepts. And we'll also look at just putting that into practice. Okay, it's one thing to have the addresses, but now we need to configure those addresses in DHCP for clients, and we need to configure Cisco routers using that same iOS and command line interface as we have on a switch. We'll also talk about some IPv4 services like port ACLs and other security related features. IPv4 is not the only protocol that we're going to interact with. We will spend the majority of the time on IPv4, but IPv6, the next generation of TCP/IP, is out and being used in some networks. So we'll spend some time looking at that addressing and how to implement it as well. And we'll top it all off with managing network devices. Again, primarily that is switches and routers. So I'm excited to start this course. I hope that you are as well. There's going to be a lot of very useful information in it to prepare you both for the real world and functioning as a network technician or network engineer, as well as passing the certification exam. So without further ado, let's get started. In this first module, we're going to be looking at networking fundamentals. This is obviously the place to start. If you're getting into the networking world, if you're looking to get certifications, you have to understand some of the fundamentals. And the first fundamental that we're going to be going over is just an introduction to TCP/IP. TCP/IP is a protocol suite, but it's also a networking model. It's a collection of protocols that work together to allow communication on modern networks. TCP/IP is something that you are going to see and utilize every single day. And so we need to get into the fundamentals of that first. We'll also be looking at the fundamentals of Ethernet LANs. Ethernet is the primary LAN architecture that is used today. We'll look at wide area networks, which is connecting your local area network to other local area networks. Enterprises can have a large, centralized corporate offices and then many branch offices. Those would be considered wide area networks. Every host on a network is going to require an IP address, and still predominantly those are IPv4 addresses. So we'll go through IPv4 addressing and routing fundamentals, and then look at TCP/IP transport layer processes, as well as applications. Now, I do want to stress that we're going to spend a lot of time here, but these are still considered the fundamentals. And so in upcoming modules, we'll revisit some of these topics and go into them in more detail. So let's start just with a definition of computer networking. What is computer networking? And you may know this already or have heard some definition, but computer networking is simply the process of building connections between systems with a particular purpose, and that purpose is to share information, aka resources. The resources could be actual data that's being shared, a Word document, an Excel spreadsheet. The resources could be a web application that's used to input order details for a company. Resources could be physical hardware, like a printer. And so, but that's the purpose of the computer network, is just to connect systems together to be able to share those resources. The job of the network itself is to enable the movement of data from one place to another. We have two broad classifications for networks. The first is SOHO, small office, home office networks. And then the second would be enterprise. Now, clearly there's some gray area and some medium-sized networks that that fall in between. You have a business that's got 45 employees but a single location. Well, is that considered a SOHO network? Probably not. Is it considered an enterprise network? No, probably not. So there's some gray area in between. But whether it's small or large, these networks are going to use similar technologies behind the scenes. Your understanding of the network is going to depend on your perspective. Okay, so in other words, the end user looks at the network just as a means by which they surf the internet, stream movies, use email. And then the network designer, the network engineer, looks at the network and sees all of the different moving parts, understands exactly how they work together, because it's necessary that you understand how it works together. The networking model is a fundamental component that serves as a blueprint or architecture for the network. It defines the components and the processes. It defines exactly how they work together. Networking models are very important. You don't build a house without a blueprint. And just the same, you don't build a network without some sort of plan. And so the networking model functions as that plan. Another name for networking models would be network architectures or network blueprints. Technically, this is a comprehensive set of documents that define the individual functions of the network. It defines individual components like the protocols. A protocol is a term that you're going to hear all the time. This is essentially a set of logical rules that define communication between two devices. Okay, so TCP is a protocol, IP is a protocol, Ethernet is a protocol. Rules that govern communication. Now, the extent to which they govern communication may not seem overly clear right away. It is very similar to, though, a language. In order for two systems to be able to communicate together, they have to be using a common language. Just like in order for you to understand me, I have to be speaking a language that you understand. We can both speak multiple languages as long as we have one in common, and that's the way that network protocols are going to work. As long as we have protocol in common, then we can communicate that way. Now, you've got physical requirements which would be included in the networking model as well. What's the wiring look like? What are the network devices that are going to be required for this particular network? Again, we're going back to the whole concept of a blueprint. Right? And then how are applications going to interact? All of these are components of the networking model. So rather than reinvent the wheel, we use networking models, and these are well-known networking models, in order to conform network devices and operating systems to a pre-built structure. It would not be a good idea, and historically this has been proven accurate, to allow individual manufacturers, individual developers to just come up with their own standards, okay? To say, well, I don't want to use TCP/IP, so I'm going to develop my own protocol and my own network devices. That wouldn't make any sense because you can't interoperate then with other networks. So the key is to use, pre-built, standardized networking models for your own network that you are building. And it's not even a question anymore. Everybody's going to do this. You don't even have to, it's become so standardized that you don't even have to worry about it. You have an operating system, it's going to support TCP/IP. When you purchase a network card or a switch or a router, they're all going to support and come pre-configured to a certain extent with the TCP/IP networking model. But the point here is just simply that model is standardized, it's well known, and there's a lot of benefit to using those things as opposed to reinventing the wheel. So today's world uses a single networking model, and it is known as TCP/IP. Now, you may have only heard about TCP/IP as a protocol, and that's accurate. It is a protocol. In fact, it's a suite of protocols that work together to help systems communicate over a network. But it is also a networking model. It defines, by very definition, it defines the communication on a network. It defines the functionality at the physical layer. It defines functionality for devices at upper layers. And we'll get into those layers here shortly. So everything has now standardized to TCP/IP, but it has not always been that simple. Originally, protocols and networking models didn't really exist. And so what I was just describing wouldn't be a good idea was actually the way that it was. Vendors would create their own proprietary offerings. And so IBM published a architecture known as Systems Network Architecture, SNA, in 1974, and that was used for many years. DEC and other vendors kind of followed suit, and the result of that was that systems from different vendors were not able to communicate with one another. You had to have products that would do translation between the two systems. Okay? And you even still dealt with that in the early 90s with systems like Novell and Windows, at least up at the application level, where they would have to have some intermediary device that was able to communicate with both sides and would translate. But it was even to that extent down at the networking level, which was even more cumbersome to deal with.